Hi, I'm Eve, and welcome to the Helodi Robotics Kitchen. In this video, to celebrate the winter holidays, I'll share with you how to make my favorite gingerbread cookies. You can also find the recipe in the video description. So if you're ready, let's get started. We begin with adding the butter and brown sugar in the stand mixer, and blending them together until smooth. Once that's done, add the vanilla and molasses, and mix once more until the mixture is uniform. While the mixer is running at medium speed, add the remaining ingredients 1 cup at a time, finishing with the flour. The mixture should now form a dough. Divide the dough into 2 halves, and transfer each half into containers. Place them in the fridge to chill. This should take about 3 to 6 hours depending on the temperature of the fridge. Once the dough is chilled, preheat the oven to 350 degrees Fahrenheit, or 180 degrees Celsius, and line baking trays with parchment paper. Lightly dust your working surface with flour, and place your dough. Roll the dough down using a rolling pin. We're aiming for a thickness of about 1/8 inch or 3 millimeters. Next comes the really fun part, where we cut the dough into figures using cookie cutters. Transfer the cookies to the baking trays, leaving some space between them so they can socially distance. Bake the cookies in the preheated oven for about 8 to 10 minutes, before transferring the parchment sheet to a cooling rack.
Perception is analyzing sensing data that the robot gets and outputting useful information for downstream tasks.
Generalized robots are not quite possible without actively perceiving your environment and understanding it.
Consider this image. You probably almost instantly recognized it as a frozen cube of broccoli, without even thinking about it. Most people probably take for granted how quickly and how accurately their eyes detect what is in front of them, even in new scenarios. But when designing perception systems for robots, it becomes apparent just how efficient our eyes really are, and the sophisticated connection they have to our brain.
The perception work that we're doing at Agility is fairly unique. We're developing algorithms that will go on a physical platform, go out into the world and do actual work.
Digit is a mobile platform, and it's real-time environment interaction. So with static cameras, you can go and play back images. They have no motion blur. You can really kind of control your environment a lot. But with Digit moving around, the effects of how you detect the first thing also subsequently affects everything after that.
If we're doing something like terrain mapping, we want to make sure that that's accurate so the robot doesn't trip on obstacles or clutter in the environment. We can also think about things like object detection or obstacle detection. We don't want Digit out there running into objects or people that it shouldn't be. One of the big challenges that we have on the perception team is robustness, especially to new scenarios that we haven't seen before.
Unsurprisingly, one of the most powerful tools to help achieve this is machine learning.
You can do vision without AI. You can do things like object recognition. There are traditional algorithms for that, but since AlexNet came out, it beat every other traditional model on this large database called ImageNet. So there's really no better tool to use.
Neural networks are computing systems that process data in ways that mimic the human brain. And when using machine learning and neural networks, there is one resource valued above all else:
Data is the most important thing in AI. without good data, we cannot build good AI. And so going and collecting more and more data as we go to more and more environments will keep getting better and better at that kind of general base model.
If we gather a lot of training data for the machine learning model in a certain environment and we deploy in a different environment,
Forgot my tools again. Such a show off.
Infrastructure fundamentally is what I call the engine behind the growth of this company. We have been building data centers since 2010. We're talking about serving maybe a half of humanity. Now when we're talking about AI, you need a similar engine behind AI so that AI can achieve the potential that we are sort of dreaming.
AI workloads are growing at a pace of 1,000x every 2 years. I mean, just contemplating what that means for our systems, our silicon, our software stack, we're in the middle of a pivot to the next age of information.
The models themselves are becoming hundreds or thousands of times larger and more complex. And what this is going to require is infrastructure at the exaflop level.
We're reimagining everything we do about our infrastructure for AI. We're creating data centers that are specific for AI. We're creating new hardware, including our own silicon. We're building out new kinds of network architectures. We're reimagining the software stack like PyTorch. Thousands of engineers are innovating on this large-scale infrastructure that's built specifically for AI.
Meta Training and Inference Accelerator. It's Meta's first in-house silicon. It was designed solely for recommendation models in mind, and it is a piece that fits with the rest of the system like software ecosystem for writing applications and deploying ML models. And it's built in-house.
By having it in-house, we are able to optimize every single nanometer of the chip. So we don't have any part of the architecture that is wasted. And that helps to bring down the power.
The fundamental target in designing this MTIA is to provide highest performance in the lowest power. And in the process, we achieved twice the efficiencies compared to today's GPUs.
Last year, you heard us talk about PaLM, which led to many improvements across our products. Today, we are ready to announce our latest PaLM model in production, PaLM 2. PaLM 2 builds on our fundamental research and our latest infrastructure. It's highly capable at a wide range of tasks and easy to deploy. We are announcing over 25 products and features powered by PaLM 2 today. PaLM 2 models deliver excellent foundational capabilities across a wide range of sizes. We have affectionately named them Gecko, Otter, Bison, and Unicorn. Gecko is so lightweight that it can work on mobile devices, fast enough for great interactive applications on device, even when offline. PaLM 2 models are stronger in logic and reasoning, thanks to broad training on scientific and mathematical topics. It's also trained on multilingual text, spanning over 100 languages, so it understands and generates nuanced results.
The images you are seeing right now have been a closely guarded secret for years. This is the first time footage of this technology has been shared publicly. A technology that has the potential to change the course of human history. A privilege Helion Energy granted us when we visited their facility. What I am sharing right now is going to be studied by nuclear physicists around the world, trying to reverse engineer the world-changing machine. This is Trenta, Helion's 6th generation nuclear fusion generator. This fusion generator is unlike any other, using a completely novel approach to achieve nuclear fusion, adapting knowledge developed for ion propulsion in space. The generator forms 2 mirrored rings of plasma on either end of a reactor, and in a 1/10 of a thousandth of a second, they fire them at each other, sequentially activating powerful magnets to squeeze and compress the rings towards the center, where they collide, converting the astonishing kinetic energy of the ions, traveling at 300 kilometers per second, into thermal energy, raising the plasma temperature to tens of millions of degrees, hot enough to overcome the electromagnetic repulsion keeping the ions apart and allowing them to fuse, forming new atoms and releasing a tremendous amount of energy in the process. This isn't the world of fairy tale. This is already happening. I watched the bright pink flash of fusion multiple times inside the control room of Trenta, safe away from the gigawatts of power surging through the capacitor banks of the reactor. It became mundane pretty quickly, to the point that my reaction to the feat became oddly subdued. But make no mistake, what Helion has achieved here is astonishing, initiating nuclear fusion reactions with ease.
Of eternity. A bond forever and beyond.
With a high bandwidth brain-machine interface, we can go along for the ride and have the option of merging with AI.
So for the initial device, it's read-write in every channel, about 1,024 channels, all-day battery life, recharges overnight, has quite a long range. This would connect to your phone and it would be communicating by essentially Bluetooth low energy to the device in your head. That's why I say in a lot of ways it is like a Fitbit in your skull with tiny wires. And then you would not be able to see the device at all. You would look completely normal and just have a small scar under your hair.